Hello, in this video, we are going to solve a system of linear equations by substitution. But first, let's get started by classifying linear systems. You can see on the screen that when a linear system has exactly one solution, we say that the solution is consistent and independent. The system is consistent when there is a solution. The system is inconsistent when there is no solution. And when the lines intersect at exactly one point, we say that the equations are independent. And when the equations are the same line, we say that the equations are dependent. Consistent means there is a solution. Inconsistent means there is no solution. And then we can specifically talk about the equations. Equations are independent when you get one solution, and they are dependent when you have infinite many solutions. That same information is here in the table as well. So we'll go ahead and get started on the method of substitution. Substitution works best when one equation is solved for a single variable. First, we want to isolate either the x or the y variable in one of the two equations. Substitute the expression found in step 1 into the other equation. Solve the resulting equation. Substitute the value found in step 3 into either of the original equations. Solve the remaining variable and write your answer as an ordered pair. As is true in most math, you can solve these more than one way. So if you solved it a different way than I have shown on the screen, that is fine as long as we have the same answer. In example 1, we can see that x is already solved. X is equal to negative y. So I'm going to substitute in negative y in the first equation for x. So I'm going to take out the x and substitute in what x is equal to, and x is equal to negative y. Now I have one equation and one variable. And now I will solve for that variable. So y is equal to negative 4. Now I need to substitute in y equals negative 4 into one of the original equations in order to solve for x. So since x is equal to negative y, I'm going to substitute in negative 4 for y. So x is equal to 4. I want to write my answer as an ordered pair. So my answer would be 4, because x is equal to 4 and y is equal to negative 4. Moving on to example 2, I need to solve one of these two equations for y. I'm going to elect to substitute the second equation for y by adding 4x to both sides. Now I'm going to substitute in the first equation for what y is equal to. So 2x plus 4x plus 8, because that is what y is equal to negative 4. Combine like terms. Subtract 8 from both sides. And divide both sides by 6. X is equal to negative 2. Now I'm going to substitute in -2 in one of the original equations to solve for y. I'm going to use the first one. Add 4 to both sides, y is equal to 0. So the ordered pair is -2, 0. Now you might ask, well, why can't I just substitute it in to y is equal to 4x plus 8? My only suggestion is I would always substitute it in the original, because if you made a calculation mistake solving for y, it might appear that you have the correct answer. I choose to always go to the original. Example 3. I tend to want to solve for the equation that has the variable that has a 1 in front of it. And in this case, it would be the second equation. I want to solve for x. So if I solve for x, I would subtract 2y from both sides. So now I'm going to substitute in the first equation. I'm going to take out this x, and I'm going to substitute in there -2y plus 8. Now I have one equation and one variable, so let's solve for y. There's my dog barking. -5y is equal to, let's subtract 32 from both sides. We get -15, and divide both sides by -5. And y is equal to 3. So now let's substitute in 3 for y in one of the original equations. So I'm going to substitute it in the second one. So I have x plus 2 times 3 is equal to 8. And that's 6, and subtract 6 from both sides. X is equal to 2. So our ordered pair is 2, 3. We can always check this by substituting in 2 for x and 3 for y in each of the individual equations, and they should be true. Example 4. I'm going to solve the first equation for y. So that means I'm just going to add x to both sides. And now I'm going to substitute in x plus 2 in the second equation for y. And we'll distribute the 3. Combine like terms. Subtract 6 from both sides. X is equal to -1. And now let's substitute in -1 for x in one of the original equations. I think I'm going to substitute it in the first one. So I have y plus 1 is equal to 2. Subtract 1 from both sides. Y is equal to 1. So our answer is -1, 1. And we would classify these first 4 examples as consistent and independent because they all have one solution. All right, example 5. I'm going to solve the first equation for y. And then I'm going to substitute in 1/2 x plus 2. The second equation, distribute the -4. Combine like terms. And you'll notice the variable is eliminated. And what you have left is false. So -8 does not equal 12. So we have no solution. We know that this is inconsistent. And finally, example 6, we already have y solved. Y is equal to x plus 3. So we can substitute it in the first equation. I recommend you put parentheses because this is minus x plus 3, the whole quantity. So we need to distribute the negative. Combine like terms, x minus x is 0. So we have -3 is equal to -3. Our variable has been eliminated. And what we have left is true. So this one has infinite many solutions. And there you have it. Hope you enjoyed this video. See you next time.